Okay, well, that's us got to 8:30 UK time here. So thank you everyone for joining tonight. We're up to 40 people, so that's good. There'll probably be a few others join as we're going along. I'll hand over to Martyn Kinder shortly. He's got a presentation tonight from paper to burning balsa. So talking through the process of going from a plan to creating the files on computer and cutting parts. There's a couple of videos, but Martyn will let you know how he wants to manage things. Just for those of you, when we do come to questions and everything, to make it easier, if you click in the participants part at the bottom and then just show raising hand, there's a little option there. Then Roger and I will be able to see when you want to ask a question, because we'll just mute all microphones during the time when Martyn's giving his presentation. So with no further ado, I'll hand you over to Martyn.
Great stuff. Okay, yeah. I feel a bit of a fraud here tonight, to be honest with you, because I'm actually presenting to people who probably know far more about this than I do. I'm certainly not what you call an established scale aeromodeller, although I must admit I'm very, very interested and very keen. Now, when Graham asked me to do this, he actually asked me to just look at the principles of actually setting up a simple laser cutter and the experience going through that. But the reality is that only takes probably about 10 minutes. It's not really very difficult and very complex. So we had a bit of a conversation, and what I wanted to do was to try to demystify some of the magic, or some of the black magic, if you like, about actually moving from a piece of paper, i.e. a 3-view of some sort, and producing something with it which is then a set of cut parts. And I was going to talk about the 3 major tools, or 4 tools I use, and talk you through the work process. So that's really what it's about. I'm expecting the presentation will probably take about an hour and a bit of time for questions. But because we're covering quite a lot of ground, if anyone wants to ask questions in between, or you're having problems, shout out by putting your hand up, as Graham's explained, and I'll do my best to pause and we'll try and answer the questions quickly. I'm going to give you a few demonstrations here as well. There's a couple of videos, 3 videos in fact, and I've got some live demonstrations of actually working through some of the applications I use, and that's always a recipe for disaster. So bear with me. I've tested it all at least once, so we'll see how it pans out. Right, so let's work it on. Before we start, just a little bit about me, because I'm fairly unknown to most people here, although I do recognise a few names here. I joined the SMAE back in the good old days when I was 14 years old, and that was back in 1970. And I had a very good biology teacher called Neville Crane. He was a superb guy, and he was a free flighter. He used to fly A2 gliders as they were in those days, and we were all interested in free flight because all we could afford. And I've basically got into flying free flight and doing contests. I was flying contests when I was 15 as a junior and so on. And I have to confess, put my hands up now, and I'll say that I really wasn't interested in scale, because I was an out-and-out duration specialist. I really couldn't see the point in scale until I met Eric Coates. And it was about the same time that Eric Coates was doing a famous series of free flight scale models, I think it was what it was called, in aeromodeller back in about 1972-73, I think it started. It was a series of about 12 monthly installments. And I looked at his models and I saw this guy, this very sort of genteel type of person. We chatted at the Nationals, I think it was in 1973 or 74. And he got me interested, but not really interested enough to do anything about it, apart from perhaps build a couple of peanut models or that sort of stuff. I carried on flying free flight and then got into radio control. And I tried a couple of other things for a few years, but came back into the fold about 12 years ago. Started flying classic aerobatics. I run the UK Classic Aerobatic Association, and that's basically, well, that's exactly what it says, looking at pre-1995 designs, and I'm still running it. I founded it and I still run it after now 8 years, and it's been great fun. 2 years ago, for my sins, I got elected to be BMFA Northwest Area Chairman, and I'm also the area delegate. For those who know BMFA will know what that means, but it's basically a pen pushing job, if you like, and trying to keep the area running as best as I can.
We've lost your audio there, Martyn.
Oops.
Martyn?
You want me to unshare? Let's unshare the screen now.
Do you have the latest version of the presentation, Roger?
No, he's never sent it to me.
Have we lost something?
Yeah, we lost your audio there just as you said that you had been doing the pen pushing job.
We're not sharing anymore with you. Your share has gone.
You're not sharing?
No.
Ah, right. Try again. Sorry about this.
Right.
It's okay.
I've just had a message up saying, right, I'm sharing now.
Yes, you are. Yeah.
There we go.
Okay. So have you heard? Have you had audio from me?
Up until about a minute ago. Yeah.
Yeah.
Okay. All right. So working with IT, I've actually worked with lots of users and tried to understand what stops them from basically getting what's the fear of IT is all about. So I think I'm pretty good at that, working with people. I've already said I'm not an established scale model. I actually started getting interested in scale models through the really three people, and that's with Danny Fenton, who's on, and Andy Sefton, who's both been incredibly helpful. But I've been incredibly lucky that we've got Gordon Whitehead as a member of our local club. And Gordon's a great guy. Sits down, he's very patient, and he brings his scale models along and he flies them. And he flies them like we fly basically sports models. It's great to watch. And his models are absolutely beautiful as well. And they really are practical scale models. I think that's what he really specialises in. So really, that's my first thank you to those three people, because they're really the ones who have motivated me. Now, I'm not a very good builder. I think Gordon will probably vouch for that. And certainly Danny's seen what my humble efforts, and nothing to write home about. But I do really want to try to build better. And I'm clumsy, I'm very ham-fisted. So anything that helps me building is always something that's is something that would interest me. And there was a thread on the Model Flying Forum, the RCME Model Flying Forum, about some guy who imported a laser engraver with a 3-watt laser head. And I thought, oh, that looks interesting. And so I ordered one, and this was just about Christmas. And it arrived at a kit of parts without instructions like these Chinese things do. So I put it together. I'll cover that in a moment. I've got to be careful. I'm not rich. I'm definitely not rich. I've seen some people's workshops on the airplanes that fly. They're out of my league. So anything that is I buy has to be cost effective. It has to be cheap. It don't have to be cheap. It have to be. If it's got to be expensive, it's got to be used regularly. But the important thing to me was that it doesn't have to be fast. I'm not a commercial organisation. I'm cutting parts for me and nobody else. So if it takes me 10 times longer to cut something out using and accurately cutting a machine than it would a commercial organisation, well, that's fine. I've got loads and loads of things I can be doing in my shed while I'm waiting. So moving on. Let's see if that works. If I can get my screen back up again. Right, so what I'm going to try and cover today, this is about the laser story. Am I still sharing? Yes, I am. What this is all about and what it isn't about. So let's set some expectations. I'm going to talk a little about the workflow, how I get from a piece of paper to cutting some parts out that are usable. And I'm going to talk briefly about the CAD programs. And there'll be some demonstrations there. For those who haven't seen it, I'll cover what we're going to cover. I'm not going to give you a course today in how to use a CAD application. This is all about just showing you what can be done. Very, very simple. All these tools only need a handful of commands to make them very useful to use, very simple to use. You don't need all the bells and whistles that come with them. Then I'll talk about the laser software. Now, why the laser software is quite important, because that actually controls the laser cutter. Then we'll burn some balsa, and I'll show what can go wrong. And then finally, we'll actually burn some balsa. And if anybody wants to contact me, by the way, after this, because I'm going to cover quite a lot, and you may want to have talk to me offline, that's my email address. We'll share it afterwards. Graham will do that, I'm sure he will. But I'm quite approachable. So please feel free to contact me. If you've got a big question, I'll probably ask you to take it offline. That's how you need to that's how you need to find me. Right, laser cutters. It happily cut 12mm birch ply, and it cost about £4,000. And I'm sorry to say that comes in out of my price bracket range. That's what I really wanted. That's what my dream was. And this is what I got. It's got actually a bigger cutting bed. It's got 500mm by 600mm bed. It's got an LED, and I put in quotes, laser diode. There's no such thing as a laser diode. It's just a very, very, very bright diode, but it is not a laser. It's 3 watts power. I mentioned that these things arrive in kits, so you've got to put them together, and without instructions, it didn't take long. It took me a couple of evenings, and it's very simple. It's what's called an XY frame. There's a head on it, which you can see in the center of the frame there, which has got carry the LED laser, and that runs along the rail on the top, and that's the X-axis. And they've got the 2 rails aside, and that drives the Y-axis. It's a two-dimensional laser cutter, and that's what I got. And I put it together, and I had a play with it, and had a bit of fun with it. But I was having a lot of problems, and it wasn't straightforward. Now, this is the difference. This is the £4,000 difference between the two. An expensive, a proper LED laser has a fixed laser source. It's basically excited photons held in a CO2 plasma. It generates a highly intense parallel beam of light, and it's basically reflected off a moving mirror. So basically, your mirror comes out, hits the mirror, points down, and it basically cuts in a very parallel beam, a very narrow parallel beam through your piece of wood. The width of the cut is probably about 1/4 millimeter. The LED laser, again, you can start to see what the problems are now. It's basically what I just said. It's a very, very hot, very, very bright LED, and it has all the light basically focused downwards through a lens, and the focus point, or the focal point of the lens, basically converges and points at your piece of wood. And it's a bit like you used to when your kids used to get a magnifying glass, you used to hold the sun, you used to burn your hand by focusing the sun's lights down that. It's exactly the same principle, except you don't put your hand there because it will do a damn sight more damage. It really will hurt you. So it's quite impressive, really, how much heat you can generate from 3 watts when you start to focus it and bring it to a point. So that's really the difference. We're talking about this, the LED laser, for want of a better word. So getting this thing going, well, it arrived as a big box of metalwork and plastic and things like that. These things usually are very nicely, all CNC cut. And it took me a couple of evenings to put it together. And when you get it, you actually get a nice piece of software which allows you to read an image, for example, like from a PDF or from a JPEG, and it will burn on a piece of plywood or something like that. The picture, it's an engraver. It basically engraves an image pointing from the software that you select, so from the image that you selected through the inbuilt software. The problem is with that is that it's not really much use for CAD type work. Now there's GBRL, we'll talk about GBRL over and over again today, but GBRL basically is the software that actually sits on the laser cutter itself. And it's important because it actually talks in a language that can be spoken to by a CAD program using something called G-code. Now, I'm talking this backwards. Don't get hung up about the names if you're not familiar with this. It doesn't really matter at this moment. The important thing is that we had to upgrade it so that the firmware was running GBRL. I then took it apart. It was a bit too big for what I wanted. I haven't got much space in my shed, as I've got to walk around my shed later on. So I cut it down, so the bed size was now 600 by 300. It fitted a lot better. Because it's on guides, you can actually make this thing as big as you want to. You can buy the metalwork for this from a seller in the UK for about 30 quid. And I could have actually made it 3 foot long by 1 foot wide, or 900 by 300, or along those lines. And it's something I was very tempted to do, but then again, I had the problem with the size. So I've settled that 600 by 300 is a reasonable size. It will do most things that I want. And if ever gets to a stage where I do need a full length of Balsa in there, then I can go ahead and modify it. And
Got off, Martyn again.
fire away. Sorry, something from me. Have you lost me again?
Yeah. We did, but you're back now.
Can you hear me?
Yeah. Okay,
sorry about this, folks. I'm getting messages on my screen saying my internet connection is unstable, so it's a bit of not much I can do about it, unfortunately. Basically, you've got to make it safe to use because it will burn. It didn't always burn through the cables because I wasn't watching it, and the cable managed to get laid right in the path of the laser. One thing that was quite important was a little fish tank aerator. Because when this thing is cutting, it's generating quite a lot of smoke. And as the smoke rises up in front of the laser, it basically diffused it so that my focal point then basically became much wider, and the cut became very, very poor indeed. I mounted it solidly. It's screwed down to a proper baseboard, and it's got a thick piece of 1/2-inch ply as a sacrificial layer. And that's basically to stop me burning the baseboard underneath it. And next thing I did was look quite literally, I set fire to the Balsa. I was quite alarmed at how easy it was to get this wrong. So I've got a bit of a walk around here now. I hope you can hear this. If you can't, I'll turn the sound off and I will talk it through by myself. But what you're looking at before I started off here, this is basically looking at the bottom left-hand corner of my little laser cutter. And I'm going to just walk around and demonstrate what the parts are, how it all goes together. And you can really see how simple it is. So this is about a 3-minute video. I hope it hangs together for you. If it doesn't, shout out, I'll stop it and we'll restart it or whatever I need to do. Because this is the short one of the 3 videos. Can you hear the audio?
Yeah. We're still on your PowerPoint at the moment.
Yeah, we don't have the audio, Martyn.
Sorry, say that again, Graham.
We don't have the audio.
You don't have my audio.
Is the volume up, Martyn?
I'll walk it through. You can hear me, so I'll walk it through myself. Okay, we're basically up to, I'm making a walk around, see what it looks like. I'll just run backwards so I can talk it through. Okay, it's an Arduino processor. I'll turn the audio off here. And basically what it does is basically drives the 3-stepper motors, and it drives the laser head there. The laser head goes down to that silver box you saw before, and there's a laser power supply, and the area there is now a stepper motor. It works on a carriage that drives across the X-range on this aluminium channel. What you probably can't see from there, but I'll show you in a second, is basically it sits on a series of pulleys, so it runs very, very smoothly. And there's a belt that drives around it and goes around the pulley underneath it, which is round on the stepper motor, so it goes backwards and forwards. Looking at there's a stepper motor for the y-axis, a stepper motor at both ends, and you can see there the tooth belt, although it's pointing downwards, goes round the pulleys, round the gear wheel there at the top, which is on the tooth gear wheel, down through the second pulley and goes through the rem. So it then moves backwards and forwards, which I'll just show you in a second. Okay, and while it's doing that, there it goes, backwards and forwards, and you can see the stepper motor would drive it across. The stepper motors are very, very fine steps, probably 1/10 of a millimetre per step. And that's showing you the other one. The bit of wire, by the way, you can see there, is my very crude cable guide to stop the wires falling in front of it. At the back there's a little fish tank aerator, which has cost me, what, a couple of quid, £3.50, I think it was, from China. It blows a very, very minute amount of air. It's called air assisted in laser parlance, but much more. Blows the air down this little air tube. I've got a 3D printed little pivot point down there, and it comes down through the brass tube, and it blows air out just in front of the laser cutter point, and it clears the smoke, and it clears it very, very effectively. It really does. It's so effectively, you're cutting tissue, it'll blow the tissue away. So it doesn't need much of a waft, but it's still quite effective. And that's it. It's really, really very simple. The important thing to realise is there are no end stops on it. There are no micro switches showing which the home positions are. And you can see at the bottom on the sacrificial board, and I've actually used it quite in anger, and you can actually see that I've actually gone quite cleanly through the balsa without any problems at all. It really does, really quite effective. So really that's basically about up. It's connected to the PC through the blue cable there. This is a standard USB cable. The PC's there, you can just see it on the desk in front of me. And roughly that is just about it. And I can't think else I'm saying now, so it can't be that important. I've covered most of the points. So I'll kill that one. Was that come across all right? Did you get the video okay there? You can nod, shake your head. I don't mind.
Yeah.
Great stuff. That was good. That's great news. Okay. So, next slide. Okay. So, there are 3 problems to overcome with this. One was get what software I was going to use to drive it. I eventually chose a program called Lightburn, which is actually a commercial package. It cost me $40. It isn't going to break the bank. And I had to then adapt the laser cutter to use so it would actually interface properly with the Lightburn software. As it happens, there are only 2 commands to worry about. One of them was to set the maximum intensity, and the second one was to set where the home position was going to be. Really was quite simple. I'm not going to show you that live because there's really very little to show you, but it's simple, straightforward. I then started cutting balsa. I've got to be realistic about this. It isn't going to cut 1/2-inch ply. Not this year. I'm using it every night. But for the majority of the materials that I use, which is basically balsa up to 6 millimeters, and for thin plywood, 32nd ply, 64th ply, it'll cut it quite happily. It will cut it. So I started off cutting 16th balsa at 1500 millimeters per minute and at 90% power, and it cut it. To this extent, I was constantly setting fire to the balsa. And when I mean setting fire, I don't mean this was as overcutting it, I mean it was burning. And the important thing was, but it became obvious, what was actually happening is the corners were becoming overcut. There was basically, instead of having a square corner, the corners becoming rounded because the burning was too intense. And I sort of then stopped at this point, sat back and tried to really understand how this is working. So what I need to do was then understand what was called laser mode. Laser mode is very, very important. When you're cutting something like a square, at a point by the corners, the laser isn't moving at all. But the problem is the laser is still turned on full blast. So instead of cutting at 1500 millimeters per minute on the corners, I was going to get 0 millimeters per minute, but the laser was still on full blast. So at that point, the wood would then catch fire because it was the heat intensity was incredible. So I thought, oh, let's see, it will turn laser mode on. This was actually a command which I had to learn in the GVRL, which is $32 equals 1, or $31 equals, I can't remember. And that was it. The next problem was it wouldn't actually cut anything. Because what it actually does, laser mode then basically looks at the speed you're working at, works at the length of the cut, and then sets the laser intensity. I was trying to cut at 1500 and I was only getting about 30% maximum intensity. It would never get anywhere near the intensity required to cut. I spoke to the people at Lightbird and I couldn't understand what I was doing wrong, and they were very, very helpful. This is one of the great things about commercial software, by the way, is that you get support when you need it. And the guy said, look, I can't tell you what's wrong with the laser cutter, but I can tell you how it works. So he wrote me a very long spiel about how it works and how to calculate and how to calibrate it. And all he basically said was just slow down. So I dropped it down from 250 to 300 millimeters per minute. It varies on the wood. Still running 90% power, and it started cutting beautifully. It was superb. I was getting some really, really nice cuts. But because I was cutting slowly now, and only the power of the laser still wasn't getting to full brightness, I was having to do multiple cuts. So I was going round and round in circles. So it would take, say, for example, 2 or 3 passes to cut through 16th balsa. The next thing is something that's called kerf. All machines that cut have to make an allowance for the cut width. Now, with a CNC cutting machine, you basically the cut width would be the width of the cutting tool, usually probably 1 millimeter or maybe less than that if it's a very fine cutting tool. On a full blown laser, the expensive one, your cut width is about 0.1 millimeters, and you can possibly even ignore that, or you put that in. You would worry about it if you're cutting, for example, a very fine cut, for example, a piece of down to a trailing edge on a wing section, which you want to drop onto a bit of thin balsa or thin plywood. What I had to do with mine, because the laser doesn't cut in a nice line straight away through, it basically cuts a very shallow V. You've got to allow a kerf, which is variable depending on the thickness of the wood. So if you're cutting a very thick piece of wood, the thickness of the cut at the top. I've lost him again.
No, still got you. There's someone got TV on in the background though, so if they can.
Oh right, sorry, but I could hear somebody talking.
It's POW.
So because you're cutting in a V, you've got to allow for a slightly thicker curve. So the curve basically is an offset to the cut, either inside or outside, depending whether you're doing an inside cut or outside cut, to allow for the thickness of the cut. And there's also a little bit, I allow for 0.3 millimeters for a single pass, 0.6 millimeter multiple passes. It doesn't matter, it's cutting on the waste side. You're not actually sacrificing the item that you're cutting. And there's also a little bit of jitter. I've noticed that through the stepper motors, but it is very, very, very marginal. And I was just mentioning making some inside cuts smaller and outside cuts larger. So what it will do, with 30-second balsa, which is what we would use for indoor modelling, it'll cut in 1 to 2 passes. Up to a 1/4 inch balsa, which I've cut as well, it takes 10 to 12 passes. It takes time, but like I mentioned right from the start, time isn't an issue to me. Okay, the important thing, a couple of things are really very, very important, is that you need to test your cuts before you start making it. You can, there's 2 things you need to worry about. One, obviously, is hard balsa is much harder to cut through than soft balsa. The other important thing is that the density across the piece of wood needs to be as consistent as possible. If you start off with a nice piece soft piece at the edges, and it's a bit harder at the middle or the sides, of course it's going to be a bit more problematic. And I'll demonstrate what happens with that later on. You can see it. Not a big problem, but you can see it. When it cuts, you'll be amazed, tissue. I've put that down. It's absolutely fantastic for cutting out tissue markings for the indoor flyers here. I mean, it cuts out accurately, and the great thing is because we're cutting down and stopping at the corners where it doesn't cut, all your tissue is held on a nice sort of mask area. So you can put your mask down, put your tissue down, all your lettering is in slap bang in place, and then you just go through with a sharp scalpel, cut the corners off, and your tissue markings are bang on, absolutely spot on. It's probably the biggest improvement I've found in building indoor models is actually through being able to finish them properly with decent tissue markings. Oh, sorry, what it won't do, it won't cut foam. I did try it. I tried to cut a set of wing ribs out using Depron. It just reflects the light gets scattered everywhere. And at that point, you've got to realize this is quite dangerous now, because these things is bright, very, very bright indeed. Anything that's bright white, don't bother. It's, again, same reasons. It won't cut thick ply. I've given up beyond a 32nd ply. It will cut it 16th, but you've got 40 or 50 passes. But what it does do, it will mark so any ply you like, ready for hand or machine cutting. So if you want to put it through a bandsaw or through a scroll saw or whatever, you'll get a very, very, very accurate markings on your wood. Far, far, far more accurate than almost anything I've ever done through any other transfer method. I've used quite a few. That is probably one of the biggest benefits I had for cutting ply. So there we go. So moving on, looking at the software. First of all, let me have a quick pause for breath. Any questions anyone would like to ask me about setting up a laser? We'll come back to it a bit more later on. I'll cover it. But if anyone wants to burning questions, fire away. Now's a good time before we get into this. No?
Martyn, you talked earlier on. You talked earlier on about using the GBRL language to get the Lightburn program to talk to the laser or the diode cutter. Could you just go over that a little bit more slowly, please, as to what the problem was and what you had to do? Not in detail, but just a bit more slowly so I can understand.
Right, like I said, I'm struggling to hear you a little bit, Doug. But on the laser, when you get the laser head, the LED laser head, it comes with its own lens. And that's all I've used so far. Focusing, there's a focus option in the software which will actually bring you down to a point. You actually look downwards and you get the smallest point you can find. Am I on the right wavelength here, or have I missed the question completely?
No, I think you're going the right way, yeah.
Okay, there are other lens systems you can buy for it, but I haven't experimented with them yet. That is something I'm looking at.
Right, okay. Well, you've got your sharp point there. You wanted to connect the machine to Lightburn, and you found it wasn't quite compatible. And then you did something using the GBRL language to make it compatible. And I could do
that. I could try that. Actually, I haven't tried it. It's something I'm looking at.
Okie doke. All right then. Thanks, Martyn.
Okay. So onto the software. As we say, I've got an IT background. I've been working with software for over 40 years. And there's always a bit of difficulty and nervousness about people struggling to adopt software, and probably because they expect too much of either themselves or the software itself. But it's just a tool. To me, it's no more of a tool, no matter what it is they're using, for example, Word or Excel, or even a pen and paper. They're all there for a purpose. You need to learn how to use it. But the important thing is, and what we all forget about it, is if you don't use it regularly, you'll forget to use it. So I'm going to talk about three main systems I use. I wasn't going to do DEVFUS tonight because I always think it's a bit too complicated. But I'm going to run through a DEVFUS solution for a fuselage. But I'm going to talk a little bit about AutoCAD, because that's what I use as my general purpose CAD program. I'm going to talk about PROFILLI, which is what I use to design wings, DEVFUS for fuselage. Then I'm going to pull the whole lot together, and then we'll put that into Lightburn. And then after that, we'll burn some Balsa. So this is how it all hangs together. We start off with a scan of a piece of paper, or what most people will probably do now would be a download 3-view from the internet. There's almost every single design that you could possibly want, including some very obscure ones, are available now as either a PDF or a JPEG. And that becomes just an image on your PC. We import it, or we use the information from that scan import into AutoCAD. We take measurements from it, and then we use that for in PROFILLI or DEVFUS or Dovewing or whatever applications you're using to design with. We pull it all in back into CAD. that we do a bit of working in the CAD program with the AutoCAD, which then allows us to generate a usable, a working file, which we then pass to Lightburn. Lightburn then sends that using, I mentioned the word G code earlier on, to the laser cutter. The laser cutter then reads the G code and it takes the G code instructions into a series of movements and laser on-off instructions and burns a piece of wood. And that's really how it goes. So, moving forward, I'm going to talk about PROFILLI first. PROFILLI is Stefano Durant's program. It's actually not really a CAD program. This sounds crazy because I use it massively. It basically used as a program which was actually written by Mark Drayler, or was a part of the development of it, a very, very talented professor who was actually an air modeller out in the States, if you've never heard of him. Flies gliders. That's his love of it. That's his love of the life. And he developed a thing called X-Foil, I think it was. And X-Foil basically is an analysis program for wing sections. And basically this was then taken by Stefano. He basically drew a graphical front end around it, so you can actually look at the performance of wing sections in certain circumstances, but on top of that, allow you to design some fairly simple wings. And when I say simple, it could be elliptical wings, straight wings, or straight taper wings, but you can do multiple paddle wings and so on. He's developed this further with a program called DEVWing, which allows you to far more flexible and a far more powerful tool, but I don't use that yet. I'm planning to move into that sometime later this year, but at the moment I'm still quite happy using PROFILLI. So what it basically does is you allows you to design. You design the layout, you just choose the wing section that you want, and you put your spars in and so on, and you can pull this up. Now I'm going to try and get this. I'm going to have to share my desktop now. Let's see if this works. Right, can you see the DevCAD
Yep, we can see that, yep.
Yeah?
Yep.
Great stuff, that's right. So here we are, we'll start off with that. So I'm going to pick out a panel that I've used. Those who've been following the Big Firedoll's cook-up on Hippocates Aeronautics will be aware that I'm building a Bok. It's a Russian 1938 design. So I'm going to use this as a sample. It's a peanut model. It's a big peanut because it's got no tail. It's a tailless model. And I thought, that looks like a bit of fun. So we'll open this up. These are all panels. These are all panels I've designed and built over the last few years. There are quite a few in there. Okay, and so I'm quite familiar with this, and it's a red panel. You can do foam panels as well, by the way, and it'll create templates for a foam cutter if you want to use it, if you've got a foam cutter. So we'll start with the Bok 5, and it's a tailless model. It's a tailless aircraft, and it's what you do is you put in your panel length. It's 185 millimeters long. This is half a wing. The root chord 152 mil, the tip chord 52, and we've got 100 millimeters of sweep back. I'm actually building in 3 degrees of washout. Okay, and I'm building that. The program will do all that for me. I'm not going to change anything. I'm just going to walk through the steps to use this. I've decided there's going to be 5 wing ribs because that was on the original 3 on the original plan. I'm trying to keep the plan as near as possible, and it will calculate the spacing of 46.25 millimeters. I can set them manually by clicking that box there. The distance 1 to 2, 2 to 3, 3 to 4, 4 to 5, and so on. So moving forward. Okay, I'm using this weird wing section because it's a tailless model. It's got a bit of reflex in there, and it's actually called it the GAL 56-3. Another aircraft I'm working on. It's a 5th scale tailless glider. It's called the GAL. It was famous for killing the test pilots just after the end of the Second World War. But it looks interesting thing is that nobody's ever modelled it before, so I fancied building it. It's a 13% thick section. And we use this as the same section as the root and the tip. But the strange thing about it is exactly the same section that was used on the full-size Bok 5. but I don't know what it was. I haven't been able to identify the exact section. Now you can actually look at this. There's three drawings. I can look at the wing section, the roots, and the tip. So all the time I'm going through this, I can check what's happening. I'm not going to sheet it. It's a peanut model, but at this point I could put a sheeting on the top or the bottom, either full length or up to a certain point. I've got a leading edge on there. I'm putting a rectangular leading edge on there. It's 2.2 millimeters wide, 7 millimeters deep, 5 millimeters deep at the leading edge. And if we look now at the root rib, my teeth back in, Martin, and the tip rib, you can actually see the impact of the size of it. Bear in mind, of course, the tip rib is actually far smaller. Okay, so that's basically what it is. And it allows me to move it. I can also tilt it, move it up and down a bit, whatever I want to do that. So I basically put a manual placement. I've forced where the center will be, and that's where I started from. Moving forward, I want a trailing edge on this. Now, the original trailing edge, which was a big mistake by my part, was that is a 3.5 millimeter wide triangular trailing edge, which is really far too narrow for this section of the size of this wing. And you can see there's a tiny little triangle at the back end of this, which is roughly the trailing edge. It's a bit of a nightmare to try and keep this wing flat. A bit better on the wingtips, but too small the root rib. But again, I was trying to follow the original Bok 5 plan, which you'll see later on. We've added some spars. Okay, I've got 6 spars in this. And I basically said I want them to go from rib 1 to 5, but on 2 of them, which I think is 5 and 6, because of the wingtip section is a little bit narrow. Okay, there's a little bit of a gap in there. Now, what this does, it actually draws you the spars all the way through, even though we're only looking at the tip rib. I've actually stopped it at rib number 4. So that one, that one is 4. You can see that's a 5, that's a 4. So that one, and those 3, I stopped 1. So it's just too thin at the wingtip to have a reliably supporting wingtip, because it's got to hold the with the tip on the tip shape itself on. I can put lightning holes in. Now, this one of the great benefits of this is that the lightning holes are actually quite useful. We're talking about indoor models now. I've no problems putting lightning holes into a piece of wood. I've tried building models with wrapping pieces of a balsa in an arc over a sub-spar, and I never got on with it. I found a real problem, but I can set the size of the lightning holes, and that's how I did. But I'm looking at keeping an edge thickness at 20%. So 20% of the thickness of the rib at that point, so 60% of that is therefore a lightning hole, and same at the back. I can set the start and finish position and so on. Well, this gives me something with a bit of stability around where the spars will be, and it's adding a little bit of benefit. Again, looking at the tip section compared with the root. Moving forward, I didn't put any building tabs on this. If I wanted to, I could put a building tab in, one real lower one, and I'll put a building tab in there. And you can see why I didn't bother, because it would be so narrow. The building tab is, of course, very, very, very handy for making sure the wing stays flat. Now, bear in mind, this has got 3 degrees of washout built into it. So the rib at the center section is actually a tiny building tab on. The tip, we've got 3 degrees of washout built in, so it's actually holding up by 3 degrees. I think that makes sense. I hope so. But that's where you put 3 degrees in. But I didn't bother with this, so I propped the washout up myself. It was just not worthy of 5 ribs. And that's it. You've done it. You can now have a look at what you've just drawn. I've done this one before, and I can now see there we are with the 5 wing ribs. This one, because I've mucked around with it, you can see on the top up here that I've got the 3 spars there, where I've got 6 spars at rib 4. So that's where it's come through. And that's it. That's it done. I've just designed a very simple wing, very simple, very straightforward, and it works really, really, really quite well. Now, we've got that into that position. Sorry, get rid of that one. That's one from early on. Cancel. Oh, get rid of that. I want to now export that. So we select the Bok 5 peanut, we print export it, we export it using the old way, because that's what I'm going to do. Okay, and I will then, yes, I'm going to do that. There, the ribs you've seen, I've got the numbers in there. export to a DXF file so that I can import it into CAD. Okay, yes, I want everything in place. Where am I going to leave it to? I'm going to call it, because I've already got one. I don't want to overwrite what I'll be working on. I'll call it peanut-new. Okay, we'll save it to there. I don't want to put it into duplicate style one. I want to put it into block 5. Aeromodeling, actually projects, block 5. And there we are. We'll save it as a DXF file. And that's it. We don't want the text files. This is putting the numbers on. No, I'm not going to bother in the way, so I'll leave those off. And I could just open it now using the default application. I won't bother. We'll pick it up later on. And that's what I will see on the screen when I open it up. But it'll be now in a CAD format. And that is it. That's now got me from working from a 3-view, actually of a plan, for I did the measurements directly from the plan. I then drew a simple wing plan form. I put the wing ribs in, put the spars in, and I've now got myself a wing. And can you actually see me on camera? Am I on camera as well?
No.
No, it doesn't matter. It's I've got the block 5 on my desk. I'll show you later on what it actually came out like. So that's it. That's basically a very simple walkthrough guide, or walking through how to use something like PROFILLI. And it allows you to really design simple wings. Most wings that we use have either a parallel planform or a taper planform. You can, if you wanted to, start off with a new panel, and we go for a new rib panel, and we can actually select elliptical. And if we put an elliptical plan in, we can now start thinking about Spitfires and stuff like that. I don't know how accurate that would be. I haven't tried it, but I have done elliptical planforms before. But you can do ellipticals, but they are pure ellipses. No, I'm not going to do that now. That's for another time if you want me to do that. So I'll abandon that. So that is basically PROFILLI. Close that down, get rid of that, and that's gone. So we've got back onto this one, and we've done PROFILLI. So moving forward, DEVFUS. Now, DEVFUS is another one from Stefano's stable of applications. He's basically got a CAD suite, which he promotes, and all these applications integrate very nicely into it. I never got on with his basic CAD applications. I've always preferred AutoCAD because I've been using it quite a long time. And I find it, probably like most people, very difficult to change from one system to another. It's like trying to fly mode 2 and then expected to pick up a transponder and fly mode 1. Some people can do it, some people can't. So this is what this is. Now, this is again part of the DevCAD suite. It's all about for fuselage design, and this is very, very, very much more sophisticated than PROFILLI, even though it's from staying stable. You basically build a structure. It's quite intuitive how to use it. So let's have a go with this. This is here we are. Again, I've been playing with it for quite a while now. I've got one or two bits and pieces. I've got the GAL 56 in there just to show what the fuselage looks like. And you can see the wing section I was using before for the Bok. But we're going to go with the Fokker. The Fokker is a quarter sail glider I built. It took me about nearly 2 years to complete it. No, I wasn't working on this all the full time. It's one of these things I kept picking up and putting down and picking up and putting down. As modelists tend to do that. But it unfortunately had a very, very sad ending when the half-inch carbon wing foot joiner failed while I was on an aero tow. I got catapulted into space by the tug, and the wing joiner failed. The wings didn't fail. The wings were fabulous. The joiner failed when there's the impact on carbon. They don't like it, and it came in from 1,000 feet. And a 5 kilo glider went down into a field of maize. It took me a week to find the bloody thing. Never mind anything else. But anyway, that's my confession for today out of the way. We're going to walk through this one. So we'll do a double click on it. And I'm going to move this across to over here. We'll start off with it. Things are a little bit more important now. We've got a project name, which is Fokker 4. A fuselage length, and this is taken from 3-view, which I've imported to CAD. So I've scaled a 3-view up to the size of 1/2. So I'm working with a small 3-view, but now at nearly 4 meter span and 1.7 meter long. an arbitrary model of the fuselage height and fuselage width. And so these are taken straight from a drawing that I'm working with. And what you basically do, you import two pictures. You import a side view and a top view using the set image. They have to be pointing left to right. These are ironically pointing right to left, so I had to reverse them. And they're quite rough. If you look at the edges, they're all jagged lines and stuff like that. But it doesn't matter. It really, really doesn't matter. All you want to do is something clean that you can work with. And then what you do then is you basically trace it. So I went a bit quick through. I'll go back again. You edit the outlines graphically. So what we do, we now draw lines around this. We put these little blue, these anchor points around the line what they want. And we basically see the blue dotted line going across. The red line there is the datum point. And underneath here is a skid, by the way. That's why I've ignored that. So that's the side view, just drawn out, including the tail cone. And then looking from the top view, I can do this only one side because it assumes the fuselage is symmetrical. So if I pull this pointer here, you can see it bends both sides. Okay, so that's all you do. You just drag them, move it to about there. That looks a bit better. We're now got a line there. If I've got an awkward shape, I can add some more anchor points in and move them in. Or I can put right angle points in. These ones at the back end are right angle points. So for example, here at the nose, to get that sharp curve, it's a right angle point. So you can see I can alter that, and it very, very nicely moves the shape, moves the position of the curve so it follows the curved line. It's a bit like a French curve is probably the best description I could put through it. It takes a little while to get used to it and working it, but this is quite a simple shape, and this is why I've chosen this one. The gull was really quite difficult to do. It was very, very complex. So we've agreed that we've now got our lines drawn into that, so we move forward and we're creating a 3D preview. I'm not going to bother with 3D view. We're creating a set of formers now. What I did was then got a set of formers. Now, the preview image, I had some nice cross-sectional images in them. I had to import them. So we're going to edit the formers. Okay, we're looking at where they are. Okay, and some of these now, I can't remember which ones I've actually got an image. So I'm going to have to guess. Yeah, this is one. So we'll have a look at that. This was the horrible image that I imported. Okay, you can see it down there. This came in. You can see it's highly pixelated. And this was the state of it. But again, it doesn't really matter. You can work with it fairly well. Again, it expects that things like formers are symmetrical in shape. So if I alter this side, it alters both sides, and so on. So you can move it about your heart's content. You notice also that this cross-sectional isn't symmetrical. That we've actually got a dent on one side, despite the fact I'm just jamming down the centre of it. Might be slightly offset, but we are quite a long way out. And you make me through this. Now, I put, I think, 5 formers in there, but I actually specified I wanted 14 formers in place. And what it does, it actually then interpolates the shape of the formers in between. So some of these that I've created, some of these have been created by the software. So it's really quite nice and quite tidy the way this gives you. So you can see what the cross sections all the way through in far, far, far more detail than you never get from a 3 view. And you get a feel for it that you know whether it's right or wrong. So we've done that. We've imported the formers. We've drawn around them, and we've now got a shape that's in 3D. And we can look up here. There's a 3D switch here, and we can have a look at it. I'm just going to bring it up, drag this up to the top. Okay, and here we've got the formers in place. Okay, you can see my top and my side angle, and if I turn the raster plans on, if I say put the formers on, there's actually more than a thought on this. So I'm turning on. You can see now which ones I've actually used to generate the manual ones. So that's a manual one there. So turn the formers off. You can see them there. There's the cross sections which I work from. But one at the tail, one just in front of the tail plane, and then we got the 3 around the wing section, and then around the front, around the cockpit and to the front. So we'll turn the formers back on again so we can see what we're looking like. And yeah, that's, to me, that's looking pretty good. Certainly for the level of scale modelling I'll do with a quarter scale glider, that's more than good enough. You know, I'm not that's going to ever enter this in a competition or anything like that. So we'll get rid of the 3 view, we'll click OK to that, and we'll move forward. And every time it's updating, regenerating the 3 view. Now, what we want to set the former thicknesses here. It defaults to 3 millimeters, 2.5 millimeters. They're all 3 millimeters, except this one here, number 6, which is where my wing joining tube will go. And it's 12 millimeters, so I'm going to put my wing joining tube slap bang through a former, so it holds it nice and rigid. So there we are. And it's quite simple, straightforward. And then we're going to put some sheeting on this now. Again, we've set the width sheeting. I decided to go 3 millimeter balsa. It's probably an 1/8 balsa, which is slightly more, but by the time I sanded it down, it'll be a bit narrower than that. And it's just a uniform thickness. You can do all sorts of clever things with this by the setting about it. You put tapered sheets in here and there and everywhere. But again, not for today, not for today. Again, you can look at the sections all the way through, what the relationship is. So you can see it now coming together. Okay, at the moment, no cockpit. We'll do the cockpit and the wing section later, a wing in a moment. Moving on. So, I need to let me just have a quick sip, if you don't mind. Okay. What I want to do is put some angle formers in here. Because my cockpit area is angled, I put inside a pair of angle formers in. So we're doing the setting now with the boundary of the cockpit front and back. And also I put a former here, okay, behind the wing, linking the wheel area, and it's just adding an extra level of stiffness in that area which I wanted. Bear in mind that the wing join is sitting through number 6, and it just adds a little bit of stiffness in that area. So you can see what happens. It actually calculates the shape of it. So there we are now with number 1. It knows it's going to cross through former number 2, so it cuts a slot at the right position. Now, I don't want the bottom bit of that former. I just want the top bit. So, but I'm going to cut it nonetheless. It allows for the thickness of the wood, so they cut a bevel. And likewise, the rear end of this one, which is this one, there's the rear end. This one doesn't traverse a former, so it gives me a full depth former. And the final one is quite deep, 8-10 millimeters. There's the third one. So that's how we do. And the rules are we split the formers. We could, if we wanted to, split the normal formers instead. Well, I want to split the angled formers for that reason. Moving on, again, it takes a few seconds. The next thing now, we've got a wing slot. Now, I'm not putting a wing slot in this because the wing's not going to sit through this fuselage. But if you had an aircraft, for example, a mid-wing aircraft, when you're building an extra or something like that, you can actually put a wing slot in there and put the wing section in, import the wing section either directly from PROFILLI, because you can do that, or alternatively, just a default wing section because there's a hole there. The red dot is where I'm going to put my wing joiner, which is like slap bang through the number 6, and it's called joiner. It's a diameter in 10 millimeters, not 12, sorry, 10 millimeter joiner there. I did increase it when I got around to it, and that's how that went together. So we're moving forward. We've got the wing defined, we've got the cockpit front and rear boundaries defined. Moving on. Sorry, I should have mentioned at that point. I could have actually also defined a slot for the tailplane as well, or is a biplane or a triplane or whatever. You can do as many as you want. No limits. So, boxes. Imagine you've got it's a power model and you want to put a box on the front to mount your motor. You can do that without any problems, or you can put boxes for batteries and so on. Then the boxes then obviously sit in between the formers. There's no boxes in this one, so I've skipped it. Moving forward again. We're moving slots, lateral sides form across there. I'm not using lateral sides in this because what I did was sheeted my thing top and bottom. So I don't have to worry about putting a fuselage sides in. But it will still calculate a hypothetical one. And you can see it sees a very, very tiny side that it could generate if you wanted it. I'll just ignore it. I don't need it. Lightning holes. Why hasn't that come up? Oh, that's the lateral side, sorry. Right. Next thing to do, we're putting quite a few stringers in this now. or he calls them spars. And you basically, what you do with the generator spar, we'll put it up. So we're going to, I'm not going to create one, but we'll just say we'll add a generic spar. Okay, where do I want to put it? Well, I'm going to put it slap bang in the centre. It could be quite useful, to be honest with you, because if you want to build a fuselage around a tube, for example, to keep it nice and straight, this is how you do it. You'd actually put a spar down the centre, build it around a tube. You know, you got fuselages absolutely bang straight all the way down the length of it. And what we can do is set the size of it, or you can put it on the edge. For example, it tells you where you want to put it. This is the place. You can line on the upper side, the lower side, the left, the right, on the outer contour, the inner contours, and so on. Loads of places you can put it. So what I did, I'll cancel that one, I'm going to create one, is that we look at, I've got one on the top. If I go down to, let's pick one somewhere in the middle. So this is former number 4, I think I'll click then. Okay, oh, by the way, it's got dynamic measurements all the time. I can measure. So I want to measure something. By left click and shift, I can measure something across 134.97 millimeters. So on this one, I've got a top spar, a bottom spar, which is going red. You can probably see it. If I just zoom in a little bit, can I zoom in? I can't remember. I'll zoom in. There we go. We've got a left one. Well, it goes back every time we do that. Then the left mirrored. So it's the right-hand side for that one. We've got the cockpit left. What I did was I put a spar in to define the bottom edge of the canopy. So the canopy now is defined left, right, front and back. So we've got the canopy now defined. And working through, you can actually then add as many spars as you want to, or longer ones. I prefer the longer ones, but that's how they are. You set this, by the way, you can actually set where your start former is, the end former, and so on. So we can skip through all these very quickly. I'll just run down them. See, there's the red one there is actually the cockpit. Moving down, there's a spar slot for the joining tube, and we're going through. Okay. I'm not too sure why I've got that one in the middle, but I'm not too worried about it. I'm not going to worry about it too much anyway, because I'm not going to finish this. Moving forward. So we've got that. Vertical decks. You can put a deck in vertically. Now, vertical and horizontal decks are great for building a structure inside, and then that will then generate the structure around it. No vertical decks on this one, but I do have a horizontal deck. I put a horizontal deck in which starts at 1 and finishes at 12. So let's have a look at it. It's there, and if we look at I'll play a lightning hole to it. This is what the deck looks like. So it's calculated. It shows you where the position all the formers are. I put a lightning hole there for the cockpit area, and I don't want a load of weight in the tail, so I put a pile of lightning holes in the back. If I want to add a new lightning hole, I can do that, and you basically just drag it into there, for example, put it central, and then and there we are. So you can put it in, create the holes, stretch it, pull it any way you like. Makes life quite easy. Very, very elegant the way it generates lightning holes. We'll cancel that one. I don't want to do that. No, I don't want to do that. Leave that. Just click OK. We'll come back to it later. So that's basically a horizontal deck. Moving on again. How are we doing for time? Getting on a bit quicker, we have to move up a bit faster. Lightning holes. It'll generate its own lightning holes. So moving forward. By the way, notice now all the formers are now split to accommodate the deck. Right. So what I've done is let it generate the lightning holes in much the same PROFILLI did it. It basically puts it in, I'm saying, with an offset, so then 10 millimeters all the way, or 10% all the way around, or 10 millimeters all the way around, which is the gap. So these are all going to be cut in plywood. So I'm not too worried about the fact I've got quite big holes in there. We're trying to take as much weight out as possible. I think Richard Krapp must be loving the conversation. It'll also allow you to build a jig to build your fuselage on. You go through this process regardless. I don't bother with a jig for this one. I have used jigs in the past. They do work well. And it basically formed it. So if you look at the jig, sorry, let me go back one. How can I do this? Yes, you can see the jig then supporting the fuselage. And that's how it basically goes together. Of course, when it gets out to range the jig like that, it doesn't. So that one floats in midair. And then that's it. We can have a look at the external shape. Okay, and then we'll bring this up to the top. So now we can put the sheeting in place and we can see what it looks like all the way around. We can hide the sheeting, okay, make it transparent. So there we are, you can see through it. Now you can see what the structure looks like inside. What I haven't got in there for some reason is the decking. I can't remember where that's gone to, but I'm not going to worry about it at the moment. Decking should be there somewhere. Anyway, I'm not sure why that's not there, but we'll have to look at it. But that basically shows you it all around, and still with the views in place. And that's basically it. That's all I'm going to do with it. So I'll cancel that because I don't want to change it. Because so that gives you a very quick view of DEVFUS. And it's taking a bit longer than I thought it would do. So we'll cancel that. We'll come out of it and move on to the next one. Am I driving you cold here, or leaving you dead, or are you okay? Thumbs up if you're happy.
No, happy. Completely different from what I've seen before, so understanding it better now.
It's hard work. I'm trying to keep this going fairly quickly because I'm conscious of the time. That's the reason why. Right, so we're back to the start from there. We'll get rid of that one now. Actually, close that and close that. And moving on. Okay, AutoCAD. I've got AutoCAD set up here. Okay, well, AutoCAD, I've used AutoCAD for years. Then I went on to a free version of AutoCAD, which then became chargeable. And then I found a free version of AutoCAD online. I'm not going to publicize it because it's a pirate copy. So this is a pirate copy I'm using. I shouldn't admit to things like that, but now I'm no longer a practicing IT professional. I can say things like that. But what I'm going to do is just basically show you very quickly what this looks like. Those, by the way, in front of you are the cut parts I did for the BOK, for the BOK 5. So, right, sorry, I'm getting your breath back. So here we go. Why hasn't that gone up? Okay, here it comes. Right, here we are with AutoCAD. There's a 3-view that I've actually already imported. This is the plan I'm working for the BOK 5. It's one of the weirdest little designs I've ever seen, and I like weird. Weird and me go well together. Too weird, my wife would say, but there we go. So what it basically is, this problem with this was that I wanted to cut the parts out using the laser cutter, and I wasn't really happy with the wing. This is the original wing, and the wing section was clearly wrong. So it starts off with a wing section. That one looks all right. That one looks all right. That was the wing 3, and it was wrong. It was miles too thin. And it had a dint in the wing when you built it. And I built the wing and I threw it away. I went off to PROFILLI and designed my own. But this was the original drawing, which I took all the measurements from. Now, how do you draw? Now, I've actually, what we'll do is I'll create a layer. I've already done this once already because this one. So we'll look at layers. Layers are like exactly what they are. They're basically one layer on top of another, on top of another, on top of another. But the great thing about it allows you to break it down a drawing into very, very nice, discrete points. And up at the top, I've already got one there called trace, but I'm going to create a new one just to show you where we start. And if I can see it, for some reason, it's new layer. There we go. It's called layer 1. We'll call it test. All right. And what I'm going to be, I'm going to give it a color. And the color, it comes up in a color picker like this. We'll pick out one that's easy to see online. In this, we'll go for red, because I know you'll be able to see it. And that's it. And we're going to make that one live. So we're live with that drawing now. And down the side of the CAD, down here on this side, we've got a small toolbar. We're drawing a straight line. So we'll pick a straight line. We'll draw a straight line over there. And like that. And if I picked the wrong layer, unfortunately, I should have done the layer. Amazing when you're trying to do things. Escape that. We'll go back and pick my layer out. Sorry, what would I be doing while I'm in the drawing mode? Here we go. So what I want to do is pick. Where's he gone? Apologies. What I want my drawing called test. That's the one I'm using. So we'll select that one and we'll draw a line. Draw a line now. Well, I should have a red line. There we are, we've got a red line. Okay, so that's basically that. We're drawing 2 straight lines. It's as easy as that. So I can now, if I want to, draw this outline very, very quickly, pick out the point there, up to that wing roof there, down to there, across down the centre section to about here. Okay, I'm going this very roughly. I normally zoom in and get spot on. So I'm zooming and see how accurate I am. I'm not a million miles out, but it's okay. And that's great for drawing straight lines. If I want to draw a curve, I pick out this other toolbar. It's called Draw an Arc. Now, what this has got a nice little feature about it, 2011, is that I can click on to an object. So I want to click on that there, on start from that point there. I'm going to zoom into this bit so you can see quite clearly what I'm doing. Now, you can see this is a rasterized program. I'm not going to follow this line exactly because it's I didn't get it accurate. But we'll say we'll start from that point. That's the midpoint of the arc. And then we'll do the second point. Then we're drawing a curve. And then we repeat arc again. We're picking up from the last point. We're coming round. And then we're drawing it round to there. And then repeat the arc again. And round again. And so on. And you see what I've drawn, although it's not actually on top of this, I normally draw it straight on top of the line. I've actually drawn a wingtip in three arcs. Can you see that? Is that clear enough? Yes, if you can, nod, thumbs up.
Yeah.
Okay.
Yeah.
So that's basically it. Now, the question is, though, how big is it? I mean, the point about CAD, you don't actually draw to scale. You can do if you want to, you don't need to. You always draw full size. So if you're working on a glider with a 20-meter wingspan, your wing would be 20 meters. The fact is, you just zoomed in on it. So I've got one here somewhere called dimensions, I think. If not, we'll create one. We'll just do it. So let's do a dimension. Let's have a look. Let's do a linear dimension, and we're going to measure from that point there to that point there, and we'll come down, and we'll zoom in. Oh, and that's 152 millimeters. Now, I think that's a bit small, to be honest with you. I actually want to see this we'll say, keep it nice and simple. We'll make it 608 millimeters chord. It's going to be a decent size. I fancy building this for a scale model. So what we'll do, we'll select everything like that. Okay. So that's everything in that box is now selected. It's got dotted lines around it on all blue handles on them. And we're going to modify it. We're basically going to scale it. Okay. We're going to stretch it from this point here. And we're going to specify the scale factor. I'm going to make it 4 times bigger. And now we've got somewhere out here. Oh, sorry, is that view, zoom, extents. And there we are. Now, I've come down to this. It's exactly the same picture, exactly the same drawing, nothing's changed. But my diameter now, my dimension is now 608 millimeters. So very quickly and very easily, I've taken a small 3 view from which we all work from, or a small plan like this, and made it very, very much larger. So I can now take my Focal 4, which is exactly what I did when you saw the DEVFUS drawing. I made it much, much, much larger. And well, it's the same drawing. Very simple, very, very simple, straightforward, quite easy to follow. And those, to be honest with you, those 3 or 4 commands I just made probably are 90% of everything I do on CAD. Because all I want to do is be able to draw it, I want to be able to draw a straight line, I want to be able to draw a curve, and I want to be able to scale something to the size I want it. The other thing you've got to be able to do is import the drawing. Now this is, if I look at the properties of that, you can see, if I bring this over here, it keeps popping up on my other screen, by the way. This is why I've got to let it come across. Come on. Here we are. It shows you basically the PDF underlay, it's called, because it came from a PDF diagram. And it tells you where it is. And all I do is, it's there. So if I pull this out, it will let me. Okay. It's telling me it's in my Martyn folder, Aero Modelling Scale, Free Flight, Mooney, the Block 5 Plan PDF. And I just imported it from that, simply by using insert a PDF underlay. Okay, it'll ask me for the path over here. Aero modelling, we'll do it again. We'll put it in. It doesn't matter. It's in free flight, sorry, scale free flight, wasn't it? VQRS scale, free flight, Mooney, Bok 5 plan. Well, then, we'll put the baby ace in. Okay, that's it. Now I'll get the option. It shows me a little preview, title preview, what it's look like. Where do I want to put it in? Well, I'll just specify on screen. Okay, so I'll start with there, and this is how big I want to make it. And what I've got, if I close that down now, I should hopefully have a very large view, zoom, extents. So we'll get the extent in, and there we are. That's my Walt Mooney baby ace. That was imported. That was as easy, as quick as that to get that on board. It really, these modern CAD tools are really much easier than they used to be. When I started working with CAD, it was on DOS-based systems, and they were awful, absolutely awful. Right, that's the end of the quick CAD tutorial. So I'll get rid of that. I'm not going to bother saving it because I don't want to cock up everything I've already got. Right, moving forward. Now, after all this, you can see now how I've actually pulled this together. So I basically created, for this test purpose, a very, very simple drawing. All right, I put it into colours. I picked the wing section from the block, Former 1 from the block. I've got a square, a circle with a pentagon inside it, and they were just drawn by freehand, by the way. And that's what we're going to burn. But I'm not going to burn the yellow ones at the top. And the reason why I was going to show you setting fire. And I thought, this is a bit stupid. You just take word for it. It does set fire. You can set fire to it. I was going to go full power on those, and I'll have a real bit of smoke in there. But that would be a bit crazy. No point in doing that. What I've got is I've got one layer of red outline for the outline. I've got blue for the spars and the stringers. I've got these in white. These in white are my test pieces, which I use to test the wood. So I basically pulled this in. It's a DXF file. I opened it up in Lightburn as a DXF, and that's one thing I haven't got is loaded at the moment. I've got a demo version of Lightburn on here at the moment. I've only got one license, and that's on my shed PC. So Lightburn just loading. Okay, go back to that. So here's Lightburn. Okay, no, I didn't know that was open. File. Open recent projects, and here's the demo one. Okay, you saw me. Sorry, I should have opened it. Showed you file open recent projects. It starts off as a DXF file, but once you've actually got this working, it actually saves as what's called Lightburn project. It doesn't break your original DXF file. So we've got Lightburn here, and what this is going to show you. We're getting now to the fun bits. We're going to set fire some wood. It creates, remember I showed you about the creating layers. Well, the great thing about creating layers is now that in Lightburn, I want to set these layers slightly different. So I'm going to set the speed and the power. So double clicking on the color, I can set the layer color, which is black. Okay, I'm going to run it at 250 millimeter per second, millimeter per minute, which is what per second. I'm running at 75%. I'm going to cut through mode. I'm not sure what it does in this. I don't think it's anything for me. Okay, I've got a kerf offset because I'm only using the black one, the black lines here, which are these two here. I'm not bothered about kerf, they're for a test. So I haven't put any kerf in, but I'm going to use 3 passes to test that it's going to cut okay. If I look at the pink, which is on the inside here, which is the inside piece, I'm going to run this one at 250 millimeter per minute, 70% power. I'm running a curve of minus 0.4 millimeters. So I'm going to come in almost half a millimeter from the inside. I do not want to touch the black. One of the things I've learned is we want to avoid charcoal, burning charcoal, because what we leave behind when you cut is charcoal, and charcoal burns very, very well. I'm doing 3 passes. And on the red, you can see you've got the guide here of it now. 250, 75. The blue ones up here I'm not going to use. I've highlighted these sections, and it automatically defines the start point for the cut. Okay, this is the control panel, if you like. I'm going to start the cut. It tells me where my job origin is. Okay, and I can optimize the cut path. Optimize the cut path basically says I will take the direction of the shortest path while I'm doing this cutting. Okay, and normally I would just start at this point. I can move it from here. I've got a console there. We can look at the controls. So I'll look at the console. I don't have a device plugged into this, so I can't actually show you the command sequence that you actually see coming across. Well, that's basically what Lightburn looks like. It takes a little bit getting used to, but it's not particularly hard. Also, tools you can draw on this, by the way. You can actually draw boxes if I want to, and stuff like that, or circles, or any shapes, random. I can put text on there. So it's actually a little CAD packet. It's all right, but this is not really what it's intended for. Not what it's intended for at all. So we'll go back to my presentation. So that's a little overview of things. Now I mentioned G-code. G-code's interesting because G-code is actually now driving the machine. What the Lightburn does, Lightburn takes your DXF file, then it takes us, right, you're going to draw this to, I've decided it's, this machine runs GBL, and we're using GRBL, and what we're going to do is now series of commands. So this is what it looks like. Don't have to remember this. G00 says we're moving in a straight line, we're fast, with lasers turned off. G17, we're going X, Y only. We're not using Z axis. G40, we're compensating for curves. If you don't compensate for curves, it draws the curves as a series of straight lines. So what it basically does is it's clever enough to say, we'll draw this curve as a curve rather than a series of straight lines. We're working in arcs. What units are working? We're working in millimeters, G21. G54 sets the coordinate system, okay, where you're going to your X and Y. G90, absolute positioning turned on. What we're going to do now, we're going to a fixed point on the bed when we start off. Then we're starting off at a G go to X0, Y0. We're going to start off there. We're going to start at the home position, which was the green dot on the diagram I just showed you. G91. Now from that point on, we're now going to incremental positioning. So what we've done, once we get to the G0 command, we're going to say 10 millimeters in, 20 millimeters to the right. From there, we move to relative position. So we move 10 millimeters up, 10 millimeters left. We're not moving to absolute values. And then from then on, we're going to say we're going to cut at 250 millimeters, 75% power, because that's what we said. And we're going to go to G0 directly. We're going to 42.19 millimeters in, 32.2 to the X and Y. Then G1, we start now moving relative to that, 24 millimeters at 750, 75% power, 250 millimeters. Simple, easy. G1X, we're moving it X by 24.3. Then we're moving Y minus 24, X minus 24, Y 24. We've just drawn a square. Then we go round again because they would do it 3 times. That's G-code. And G-code is, if you get into CNC machines and stuff like that, G-code is a useful thing to know. Not to go and know it off by heart. You'll never do that. But if you're ever debugging what's going wrong, understanding this really does help. Right. I'm going to give you a demo. I'm not going to talk this through. You just sit and watch and be captivated. I hope you can see it. I hope this video holds on. We're going to start it off. You can see it now moving straight out. We're going to draw the square first. So we're moving it in the square over this side. And the laser's turned on. It's quite bright. You can see everything went very dim then as I tried to compensate for it. You can also see, looking at it, when it gets the corners, the laser goes off and comes back on again. So we're no longer setting fire to the corners of the wood. And it's doing this 3 times. It's going to burn everything that you can see on the left on the screen. So it takes a little while. So I thought it'd be a good idea now, while it's doing this, you're captivating it. There's one thing you want to watch out for later on. It's not particularly obvious now, but you can actually see the cone of light. You see, it's only tiny. It's not like it's going. I exaggerated in my diagram, but you can actually see quite clearly it's thicker there than at the point here. And what you see the smoke, by the way, coming up, being blown away as it's being caught in the light. So my little wafter over there is just wafting it away quite nicely. Now, squares are quite handy. The great thing about doing this is I'm actually now testing the wood. It's a piece of 30-second balsa, but it's not particularly evenly spaced grain. You can actually see down this side over here, okay, it's definitely a bit denser than it is than they're down here. So it's coming up now, it's going to draw a circle. So we're into the circle now. It takes 8 minutes to cut all these parts. So there we go. Has anyone got any questions while we're doing this? Because it's time's marching on, and anything you want to ask any questions?
Yes,
Also,
Martin.
I'll turn the audio off for you. It's irritating.
Hello there, Martin. This is Steve Kessel here. I wondered, how careful do you have to be about the reflections from the laser? Do you need to wear goggles?
Oh, right. If you see behind there, the little green, see the green things there? They're
Yes.
basically they're a pair of goggles which actually totally cut out the blue light completely. You can see it, but you can't really see it. You know what I mean? Not like you can see it now. I've got to put my hands up and say I'm not exactly Mr. Safety, and I did put them on originally, but my problem was that I couldn't really see what was happening, so I then took it off. So I just make a habit of not looking at it. You know, it's the way you're seeing now. It's far, far, far brighter than what you can see in real life. I would probably say 10, maybe no more than that. Probably 100 times the intensity of what you can see. It's very, very bright.
Wow.
David.
Martin, I've got a question for you. Like, I sit in front of my laser most days, and what are you doing for ventilation extraction? Because I can tell you need to give your lungs a bit of a favour from inhaling that stuff.
Right. Sorry about this. I'm just I just realised my camera's turned off for some reason, hasn't it? Sorry about this. I'm struggling. Yeah, I don't know why. Anyway, never mind. What's happening? So can you go update what's happening now with this wing rib? The wing rib's actually is in 4 parts because I cut little gaps in where the spars were. Never got around to finishing it because what I didn't want was to be burning a square on top of the square because it becomes a little bit odd. I've actually got the parts in front of me at the moment, so I can't turn my camera back on. Let me think. No, it won't let me do it.
We could just wait to then, Martin, once you've stopped sharing the screen, and then we can go to your video.
Yeah, is that what it is? It won't let me do both.
Yeah,
Okay,
so
I'll let this finish off. It's well on the way through this now. So it's cracking through. So I'll just fast forward a bit because I want to show you cutting a bit farther. So if I just come to about here, and a bit farther forward. Right, cutting the former now. We haven't at the moment. We're still cutting the parts marked out in red.
I think you might have missed a question there from Gwyn as well, where he was asking what are you doing for ventilation. Gwyn has as part of his business, he's sitting in front of lasers all the time. So are you doing anything for that, or?
Sorry, so ask the question again, Graham.
Gwyn, do you want to ask?
Yeah, I will. Martin, basically, I sit in front of one of these most of the hours of the day. Are you doing anything about extracting the smoke out of your workshop? Because you should be.
That's not all I've got. All I have is that tiny little air pump to blow it away. You've got to bear in mind, I'm not cutting as fast as you are with your professional laser cutters.
Yeah, but it still generates a fairly toxic
some guys have gone
smoke.
for big air pumps on these things, and they're pumping sort of 50 litres of air a minute. This is pumping probably 1 litre of air a minute at the most, I would imagine, if that. It's adequate.
Yeah.
It's quiet as well. That's the other good thing about it. It's not causing any vibrations.
Can I suggest that you try and ventilate your workshop, because believe me, it plays havoc with your throat after a while.
Oh, I never mentioned that. Sorry, well, it's actually a good point. One thing you can't detect from doing this, you can't get the smell. These things stink when they're cooking. You can't. Unbelievable smell from it, and especially because my baseboard here, my sacrificial layer is actually plywood, and it gets the resin. The resin really, really reeks. I'm going to put an extractor fan in to get rid of the smell and stuff like that.
Yeah, probably sooner than later.
So anyway, we're cutting the spark box at the moment. We're going to crack through that. I'm only doing one pass on the spar slots, not 3, because I don't want my spar slots to be too big. I don't want them to burn. I'm quite prepared to open them up. So we'll cut the long runs now. Let them crack on.
Martyn,
yeah.
Martyn,
Yes.
Doug, I'm still struggling to understand the relationship between the G code that Lightburn produces and the GBRL code
Right.
that
Okay.
the cutter uses.
Right, okay. You've got your CAD DXF file that's appeared in Lightburn.
Yeah.
Right. Like that needs to instruct convert the DXF file as a series of movements.
Yeah, I understand that, and I understand the G code, but I don't understand the interface between that G code and the cutter, where the cutter is using this GBRL language.
Right. What happens with GBRL? What GBRL is basically talking directly to the hardware.
Right.
Okay. So what you're saying with GBRL, we're just saying turn the laser on at this intensity or that intensity.
Yeah.
Okay.
So
the G code
software,
is machine independent.
Yeah, I understand that. So the GBRL code tells the mechanics what to do, but it is also capable of understanding what the G code is telling it. So it understands the instructions that Lightburn has produced, and translates that itself into the motion of the machine. Right.
That's it. That's exactly what he's doing. That's the important thing about it. The G code is not machine dependent. You need something which actually, I always think of it more like firmware. In the old days of firmware, which basically sits on the machine itself. It's like almost like the operating system for the laser cutter.
Yeah. So does GBRL talk to anything else other than G code?
Say again, sorry.
Does GBRL then interface with any other form other than G code?
It does, but it depends on the machine itself. Okay, so this is just coming across now. There's my cuts now, and I pulled it out, and you'll see what it looks like. So that's it from the top. I think those cuts look pretty neat, nice and tidy. That wing ribs come out just about perfect. And as a tip pops out, the lightning hole pops out of it. You can see that where the harder wood though is down the center, well, I've got to just finished off with a scalpel. But it literally is tiny. You can see I've gone through. I've got one stringer there which actually overcooked slightly. But that's basically what happened to it. I've got that part here. I'll show you in a second when I switch this off. So that was a quick demo of what it looks like when it's working. Right, this is my shed. I've been asked to, as a I've got a few minutes while with the shed. Now I'll go back onto my camera, onto me, and I'll actually show you the parts I've actually done. But I'll do this now while we're in a second. This is my garden, by the way. So I'm going to walk through this. I'll turn the audio off, and this is it. So here's my garden, 9:20, Sunday night. There's my motorcycling mug there on the chair with the piece missing on the back, and it's my shed. You see at the time. It's just going dark, and into the tomb. So here we go, and be horrified now. It's 13 foot by 9 foot. It's full, absolutely jam-packed full. I can't hardly move in there. So we started off. I've got anything that can go on the door goes on the door. We got it there, as you can see, my 3D printer, and I have my laser with a PC with it. That's where it sits. The PC lives in there now. That's my old desktop, my old laptop PC. Storage underneath. I've got glass fiber kits under there. There's balsa, there's jigs, there's plans over in the corner, plans coming out your ears in there. Plans piling up, the chippy there. Danny will recognise that one. Okay, scraps of balsa. That's my main balsa supply. That doesn't really do it justice. There's probably about 150 sheets of balsa in that pile. There's a kit there for a mass build for the model fly, which I've started. I've got wing racks up there with bits and pieces in there. I've got my Fury there down here. That's going on my bench very shortly. As soon as I finish one of these two I'm on now, the Fury will be back on the bench. I feel very embarrassed. There's a Swordfish in the corner by there, which was a kit scale, which I've never finished. I've got a few that I've never finished, by the way. I'm a bit bad like that, a bit naughty. So, come on, move on a bit, Martin. What am I waffling on about? I was going on about the Swordfish, I think. Right, there's the Fury. There's two boxes. I've got peanuts in it. That's a PSS F86 Sabre, which is getting very close to being painted. In fact, it's been painted silver since I did that. Tailplane for it sat there. Pillar drill straight from Wicks, 55 quid I think it was. My bandsaw, that's 52 years old. It's a BBS 20, it was my dad's, and he bought it when I was 12 years old. I remember it when he came in. My dad used to buy lots of tools. Never had a clue how to use them, but he used to buy lots of tools, on some of which I've managed to acquire from him over the years. He's passed away now, so you probably wouldn't miss him. I've got Delatel down there. That's my naughty corner, by the way. That's modelers that have failed in one area or another or are in for repair. So I've got a little, I've got my rearward speedster in the back there, which is now just about ready to go, but the wings, I've got a problem with the tissue on the wings. And I've got the Lysander there, Andy. That's my free flight scale, Buck and Chung man, I think it is, like a motor man or a Meister. But it's probably going to go to, it's going to be a free flight scale, but it's electric powered, and I don't want to put radio control engine cutoff into it, which I'd have to do. I think it's not what free flight's about for me, so I'm going to probably make it to radio. Those vinyl masks there are for the rearward speedster and for something else. I forgot what else. Oh yeah, for the Delatel. I'm going to repaint that. That's basically my bench area where I've got tools area. I've got stuffed tools and more drawings, plans piled up. That's the charging area. There's a Weber 6-speed 60 in there for that big F3A there. There's my peanuts. So there's the Bock, by the way. That's what the Bock is. There's the Baby Ace, the Bock. That's a weird looking model, that is. Still under construction. And that's actually a genuine colour scheme. There's a peanut Fred with a green leading edge there with a G or AS. And on the, sorry, I didn't really stop that very well, but BUA, that's one I didn't do that. They were hand cut letters and they're nowhere near good enough. That's why I never bothered finishing it. That's hand cut as well. That's my own design. That's a Citabria champion again. It's nearly finished. Scale rib spacing. It looks all right. I'm quite pleased with that, to be honest with you. I've got a lot of work's gone into that. It's taken me a long time. I built it on holiday in Italy last year and then covered it and finished it over here in the UK. So take building board every time I go, everywhere I go on holiday, say that. Another 55-year-old Black & Decker in blue, pre-orange days, I think it was, with a sanding disc attachment on. That's my main sander. Behind that, there's a scroll saw, which I don't use very much at all. Bit of a disappointment. I remember asking somebody, how do you keep the dust down? I have a massive problem with dust in there. There's building boards everywhere, by the way. That's my average size building board. I'll turn around in a second, look back down my bench, and you'll see my 2.5 metre building board, which is what I do the big gliders on. It goes right down to the corner. That's a decent sized building board, that one, a proper one. I use plasterboard, by the way, for my building board material. Nice and flat, cheap, dead easy to replace it. The Delatel is waiting for a coat of paint, and then we'll try to get that one working again. My gliders kind of fly radio control thermal soarers or under the back. Oh, best useful tool, that's Shack Frack, that is. I use that a hell of a lot. And that's it. I've got measuring sticks hanging down. That's my spray area where all my tools, spray bench and paint underneath. I've got a couple of cupboards to the rack, which I'll go back to, where my radio gear and engines are in and stuff like that. It's just a right blooming mess, as they say. The roof is plastered with drawings of aircraft I've done, bits in places in place. I'll chip you up there as well, I think. And that's it. That's a walk around my shed. End of.
Very good.
Okay. That was it. That's me. So I'll turn this off. I'll stop sharing the screen. Stop the share. I should get my camera back now. Hi, Andy. Start video. Right, I should be back on again. There we go. Right, here's the parts that I cut out. That was the wing rib. Okay, and I haven't touched that. That's straight how it came out. Can you see it? Not quite. Okay, I've got some quite nice 16 square slots there. Okay, and they burnt away. I've still got the charcoal down the outside. I always thought it was ashes. I thought it was a burnt. It never occurred to me it was charcoal. This was the pentagon I cut. It's exactly the right shape. The former I used. It's there you go. Oh, just broken it. There's clumsiness for you. That was the broken one, but you can see how it's come out. It's usable. I wouldn't be perfectly happy with that. Now, as I say, you always practice with one earlier. This is one I set fire to, and you can see what it's like when it burns. It genuinely does burn, and that was the circle with the pentagon, I think. Yes, that was a circle with the pentagon. And the reason why that burned at those points is the 5 points of the pentagon. And it occurred to me afterwards, I was actually burning on the outside of the pentagon and actually setting fire to the wood on its second pass. So to show you, they do burn, they really do set fire. So that's basically what I got. And there's the box. If you look, you can see through it, you can see the wing section, the wing ribs, all the cutouts and the lining, and that's it. That's the box, and it does glide. I'm still waiting to do a powered flight with it, but there we are. So, folks,
Good.
that's it. Thanks for that,
Martyn.
Richard. Okay. That's it. Any question? Any more questions? If I can hear them, I'm really struggling to hear tonight.
Martyn, I've got one.
Yeah, David.
Martyn, if you were to build another laser cutter, would you use a 3-watt LED again, or something different?
Good question.
More powerful or less powerful?
Right. I'm actually thinking of upgrading it to a 10-watt laser using the existing tool, because that will just give me that little bit extra oomph to get through thicker balsa. I'm not convinced about using it for ply. It's handy to have. It will go through 32nd ply because I got the parts for that Classic F3A using the laser cutter. The problem is that laser cutter, the laser power is actually modulated by the voltage. When you go to the higher power ones, it has a separate control signal. So if I have to change the laser, I also need to change the, I'll put some back in. I also need to change the control board. Now, when I retired 3 weeks ago, I actually got a long service award. I got 500 quid. And I'm actually thinking of buying a CNC cutter for cutting ply. About the same size, 600 by 300 millimeter bed. Just to give me that bit extra. It's not for cutting out the balsa so much, or the thick ply. It's actually for cutting out light ply. I actually quite like using light ply for the wing ribs. Very, very hollowed out, by the way. I take a lot of wood out of these things when I'm using them. But it gives me that bit of security that I know everything is accurate. So at the moment, the jury's still out on whether I'm going to spend me 500 quid on that. John Mitchell just asked, what does PROFILLI and DEVFUS cost? PROFILLI you can't buy anymore, but unless you ask Stefan very nicely. The DEVFUS and DEVWing, they cost about 50 quid each, I think. So it's not cheap, but they're very, very, very powerful, as you've seen. I think, what's the general view? Were you impressed with DEVFUS? You can see how useful it can be.
Definitely.
Not bad, is it?
Mm.
Yeah, I mean, you've taken me way, way out of my comfort zone tonight, and in terms of what I've had exposure to, I think we'd still need quite a bit of work to do, but yeah, it looked workable for me.
Yeah. Oh, there's the prices from Greg. Thank you, Greg.
Can I just ask a question about material thickness?
About the what, sorry?
About any, because you've got no Z-axis adjustment.
Yeah.
Do you need to compensate in the software if you're starting, say, with 6mm balsa rather than tissue?
Yeah. When I'm doing the cut, when I do the cut, basically I'm cutting thicker balsa. I basically increase the kerf very slightly. Only marginally. I'm not talking about millimetre. I maybe go from 0.3 millimetre, 0.4 millimetre. And it's like when doing a multiple cut of anything. I just think put it on the slightly outside. I've got to be honest with you. You only really notice it when you get down to the trailing edge, okay? And that is supposed to be 1.5 millimetres wide, which is what the section of the trailing edge was. And it's slightly less, it's 1 millimetre. So I lost 0.5 millimetre in the cut.
Yeah.
If I was cutting wing ribs for something like a normal outdoor size model or a glider, you probably would never even notice you've lost 0.5 millimetre. But you do notice it on something this size.
Yeah,
so
but
that's where it becomes very critical.
But the actual focus of the laser is always at the bed level, is it?
It is, yeah. That's what you do. All the final cut information is all done at the laser, at the light burn level.
Yeah.
Up to that point, everything is actual size.
Mm-hmm.
Do you have the possibility to adjust the focus height? Can you change the height of the laser?
Sorry, George. I know, George, you have to start again. Sorry, I missed the start. It dropped out.
It is actually a continuation of the question by Ian. Do you manually adjust the focus depending on the material thickness? The focus point. Can you adjust the height of the LED emitting device?
Yeah. Sorry, George. Unfortunately, to me, it's dropping. You're clipping very badly, so I'm only getting part of your conversation.
The question is whether it's sort of follow on to my question as to whether you can adjust the height of the focus. So, for example, if you wanted to mark out, if you've got a thick former,
right? I understand.
To do an accurate. If you want to mark it accurately for cutting with a saw, you want a fine line. So, can you actually adjust the height of the focus?
Oh, right. Sorry. Let me explain. I'm sorry, George. I understand the question now. One thing I never made a point about. Okay, when you're basically focusing it, you can actually alter the focus over quite a large range. Now, according to the inverse square law, if I actually brought the height up halfway through the distance, so I brought it, at the moment, the focus is about 3 inches, so it's 75 millimeters. If I brought that down to 37 mil, okay, I'd have twice the power. So I'd have equivalent to a 6-watt laser at that point. But the problem is that the V of the cut will be much sharper. So you would then have the second problem then of the kerf problem. So you would, and certainly on thicker wood, you can actually see the difference between the top and the bottom, where you get a much finer cut at the bottom and a distinctly thicker cut at the top. Only because I'm looking for it, not because it's a problem. Okay, it hasn't been a problem so far. What is more important is allowing for the thickness of the cut in the first place. Does that answer your question, George?
Yes.
Sorry about that. I'm struggling with being deaf doesn't help, and it's very hard work here. Is there any more questions?
I have another one. During your market research, you've shown us 2 different models at the extreme spectrums, price range. I imagine for me, for example, or for you, for free flight models, the version you showed or you bought is adequate, let's say. But for the, let's say, bigger models, for 3 millimeters and things like that, thickness and more, it is a bit too weak. Are there any tweak sizes in terms of power or whatever? Because you don't go to 3 passes for 1 millimeter.
It's a very fair point. I mean, you've got to bear in mind, this is really is the bottom end of the scale, you know, of when you're cutting it. What I wanted was to be able to cut a set of wing ribs for a taper from a CAD application accurately. Speed didn't matter. Now it will quite happily cut 3 millimeter balsa. One thing, for example, this one is, I don't want to get too close. The wheels on this, okay, are cut from a laser cut. Okay, they're cut from 3 laminations of 3mm balsa, with the centre layer solid, and the outer are basically cut. So I end up with a hub on the inner perimeter of the tyre, and they're cut it very, very, very accurately. For cutting things like circles, where I've never managed to put a circle in my life accurately, it makes a massive difference. So things like that is wonderful. And of course, when you've cut the circle, all I've got to do is then round off the inner edge of the hub and of the tyre, and I've got a tyre. Now, it doesn't. I'm talking a lot here about indoor models, but I'm still exploring what it is capable of. It's capable of far more, but for the percent of my construction, which is cutting out parts for wing ribs and so on, which really can be very, very hard work. This is actually it does what I want for it at the moment. But if I had to cut a set of wing ribs out of 6mm balsa, I mean more than 1 or 2, I'd think twice whether this was the right tool for it or not. Okay, but I'm still saying the point I've made before. It is not really a tool to be used for cutting plywood. Not like it is at the moment. Even at 10 watts, I don't think it would be that good. It would get through a lot quicker, but you're still looking only at 3 times the power, and that does not necessarily make it 3 times quicker.
Okay, thanks.
I've got a question for you. It was actually just more a comment, Martyn. When you're importing your PDFs into your AutoCAD, I would suggest there's a better way to do it. When I do mine, I convert my PDFs to a TIFF file, and then you can attach them to the AutoCAD. And what happens is there's 2 things you get out of it. One, that your graphics card doesn't work so hard to deal with a big PDF image, and 2, when you zoom in and out of it, you don't get that distortion of the pixelation of the PDF. So if you want to try doing that at some point, you will see the difference.
It's a fair point. The pixelation is a big problem when you're importing stuff. Yeah. After a while, I just go down the center of the pixels. But if you are working on basically a PDF file which you've blown up to 4 meters, you're looking at a line width or something like this, and it starts to get hard work. So yes, you're right.
That's why if you convert it to a TIFF, you won't get that issue.
Yeah, it's the difference. One thing, a couple of terms you may well come across is a rasterized image and a vectorized image. A rasterized image is basically a picture. It's basically a series of pixels on a screen. That's what you're looking at now. It's a rasterized image, okay? Or on paper, it's the lines. You blow those lines up, those lines will then pixelate eventually. A vector image is a single line which goes from point to point.
Yeah.
And that is what you're aiming for. You want to be on a vector image as quickly as you can.
Yeah.
It might be quite a good thing when to see a comparison in the future. You know where this is going, don't you?
Yeah. That's for nothing.
Where we could have a little tour. We could have a little tour of your facility, and we can see your laser cutters in operation. You walked into that one.
Yeah, I know that. I realised that was coming. That's all right. But it'd be interesting to show you the different end of it. Greg Lepp's got one as well. But it's you talked about the price of the machine that you initially in your unit. Whilst that might be the case in the UK, you can actually buy direct. Like I bought my laser from China. It's a 1300 by 900 bed with a 100-watt laser, and they delivered it to a port of entry in New Zealand for $4,000 US, and that was $6 years ago.
At the moment, US dollars, I said about £4,000 what it cost.
Yeah, but by the same token, it's a completely different animal.
It is. I'm not trying to pretend they're the same thing. There's no way about that. No, there's no way. I would love to be able to afford a proper laser. My second problem is where would I put it? As you say, I'm very short of space. Because I could take a bit more space up than that.
You might find though that if you look around now that some of those smaller lasers, even if they're 30, 40, 50 watt ones at 600 by 300 beds, won't be anywhere near that price. And if you want to take your chance and buy something out of China direct,
Well,
you do it with care.
Half the price. No, I think I'm spending that much money. I would like to know what I'm buying. That's the problem.
Yeah.
So I'm prepared. I would pay a premium for that, but at the moment, it's not an option. I mean give it.
No.
I'll save me pension plans out over the next 12 months, and I might treat myself.
Think of all the money you're saving by not going to the pub.
Okay.
No fun.
Pubs are shut.
Got a question, please.
Are you all happy with that? Is there anything else? Call it a night?
Gordon's trying to ask a question, but you're a little bit quiet, Gordon.
What I want to ask is, what program do you use to convert your PDF to a TIFF? When? Did you hear
Sorry,
that?
Gordon. Gordon, what program do you use to convert what? Sorry, Gordon.
The PDF to a TIFF.
The PDF to a TIFF.
Oh, right. Okay. That's another way of doing things. You can. I basically get the PDF file, and I basically what you need to do is get it as clean as possible. You need to take all the text out of it, so you erase as much of it as you possibly can. And then I just use an online converter, PDF to DXF, and I'll try a few of them. And some are good, some are bad. But the best way is really to start off from my CAD programs. There's no point in going to PDF and then back to DXF. I've never had any great success converting a PDF file from, for example, from a plan to a DXF file. It just does not. It doesn't come out too well. It's too noisy, and you get spurious lines appearing and things like that. And so I've never been successful with that one, Gordon. I'm sorry.
And Gwen, what was it that you were using to convert to the TIFF?
I have a full version of Foxit PDF.
Foxit, yeah.
Foxit, and that's got quite a good converter in it. I've used that quite a bit. Yeah, it's you can convert a PDF to a JPEG or a TIFF or whatever you want, really, at the end of the day. I don't know if the standard sort of free version does that. I would doubt it, but Foxit, it is a very good converter, and I've used it for years.
Right, I'll bear that in mind, because I like Foxit. I use a Foxit reader, and I'm very, very impressed with it. I think it's great. So I'll look at that. Thanks.
You can adjust the size of the file that you get out of it as well, which you have to do. You can get a really big file, or you can get a much smaller file that's much more manageable. But it comes back to having that TIFF file to end up with a smaller file to manipulate within AutoCAD. And it's also a difference between importing it and attaching it. If you attach it, it works a lot better than importing it for some odd reason. And it will also import in the white format, so you get the whole, like a normal PDF look. Whereas what Martyn's done is that if you bring it in another way, as use it as a PDF underlay, it will be that black and white reversed image.
Yes, which is nice to work with.
Yeah,
much nice. But far better. It's better to use that than using a JPEG.
Yeah.
Right, thank you.
George, if you got another question?
Yes, I think Gordon asked about converting PDF to DXF.
He asked, how would you convert a PDF to a TIFF file?
To a TIFF file. Okay, this is done by the software, but it is not possible to change a PDF to a DXF file.
It is, but it's rubbish.
The way to convert a PDF into a TIFF file is in Photoshop.
But
yes, it can be done with Adobe software as well, but I'm talking only about DXF files, which are the usual files for CAD work.
PDF to DXF is really hard, and I've tried a few of them, and like Martyn, they give you end up spend more time editing the drawing than it does to take to actually trace it in the first place. So
I always think it's quicker to draw. In fact, that's why I prefer to take direct measurements and then just work from a direct measurement and then just draw it out in CAD. If I have to, it's so much easier. And you've got something which is yours to work with.
Yeah. Thanks, Martyn. Have we got any more questions?
Yeah, I've got one, Martyn. Did I spot a 3D printer in your man cave?
You did.
What have you been using that for then?
Right, I've quite a few things. I've printed off the cockpit for the recently. I picked off the cockpit for the Sabre, including the ejector seats and stuff like that.
All right. Yeah.
I did all the fittings or the parts on my Chipmunk with it. So things like the panels and stuff, very, very thin. And inspection things, because they're quite light. They're very, very light. I printed a set of wheels for the Fury, which have come out really well. Really quite pleased with those. I don't know. I have to say I haven't really got into 3D CAD yet. I'm getting there. I'm using FreeCAD because it was free. But I do notice that AutoCAD 2011 has a 3D CAD version as well. But at the moment, for what I use it for, I'm happy with FreeCAD. So mainly modelling things. I don't think, in fact, I don't think I've actually made it for anything else. Oh, I've made tools and stuff like that and bits and pieces for my 3D printer, which everybody seems to do. You buy a 3D printer, then the first thing you do is make parts for it. I never quite understand the logic behind it.
Was that a glue it together yourself job as well, the 3D printer?
Does it what, sorry?
Was it a glue it yourself together?
Oh yes, yeah. It's an ANET A6.
602, isn't it?
ANET A6 is what it is. I've had a few problems with it, to be perfectly honest with you. I don't want to digress too far tonight, but the biggest problem I have is actually getting the filament to stick reliably. Once I've got the filament to stick down, and if you notice back in the video, there's a kind of spray adhesive which is by the 3D printer. What I do is I spray the bed with that, and then that allows the filament to stick. And once the filament sticks down, it's fine. It works very, very well. I've tried various things. I've got a glass base on it, and but nothing's been really satisfactory. I've even used masking tape. You've put masking tape down, and the filament will stick quite happy to the masking tape. But it wants to be reliable. There's nothing worse than starting off. You get halfway through, and then you find your item you're printing has broken away, or it's turned up in a molten mess of plastic. Very, very frustrating when that happens, especially halfway through a 15-hour print.
Yeah.
If I can just interrupt there, our sort of friends in Scandinavia, it's getting a little bit late now tonight, and they're all sort of like messaging me to say like thanks very much, Martyn, but they have to head off. So 3D printing, there's a couple of guys who are quite keen to do presentations in the future, so I think that could be quite a long evening when we start talking about that, because again it's something that a lot of us are intrigued about. But has anyone got like a final question for Martyn before we go?
I got a quick question regarding the software DEVFUS, etc. I wonder if there's a DevWing application. Do you know what the difference between that one and PROFILLI or whatever you call it?
Well, you saw DEVFUS. I gave a demonstration in DEVFUS. DevWing is much more like DEVFUS. You actually draw an outline accurately in the way that we imported the outline for the fuselage. You would import the outline of the wing. So, for example, if you imagine you're drawing a hurricane. Well, let's take a hurricane, which is a good example, because it's not elliptical. It is curved. There's definitely got curves in there. And you can actually plot very accurate then the shape of it. It also allows you to do lots of clever things, like, for example, putting diagonal ribs in and stuff like that, and a lot more flexibility on things like tapered spars and so on. That allows for flaps and ailerons and various shrouding and so on. So it's far more powerful. But I've always been happy to do those clever bits in CAD if I had to do that in AutoCAD. But having said that, if I ever got to the stage where I wanted to draw up my own hurricane, I would look very carefully at something like DevWing, mainly because I'm really quite impressed with DEVFUS. DEVFUS has been an eye-opener to me to be able to build a very accurate fuselage shape and know it's right. It makes a massive difference. Very good indeed.
Nice.
I've got a question.
Yep, John.
When are you going to get a bigger shed?
Oh, sorry.
When are you going to get a bigger shed?
Oh, a bigger. Oh, yeah. Sorry. That was my wife keeps trying to put my bed in there. So I said, if I do that, I'll need a bigger shed. So what we'll do, we'll negotiate a bigger shed, then negotiate the bed coming back in the house again. Yeah, I need a bigger shed. Definitely need a bigger shed.
Yeah,
we all do. I always look at things like sheds as the same as waste bins. You only ever need something bigger when you fill the last one up. You know, they get bigger and bigger. I mean, I put that shed up to actually restore a motorbike in it, and it was tons of space in there. Then I started building model aircraft back in there again, and I ran out of space so quickly. It's embarrassing. So it's a problem. I've got to sort something out. I don't bear in mind that's not a model store in there. The garage is full of aeroplanes. I actually thought of actually converting the garage into a shed as well, but that would be pushing it too far. I need somewhere for the 4 motorbikes.
Thanks very much.
Okay. Yeah, it's a good question. I need a bigger shed, no doubt. Everybody needs a bigger shed.
Okay, well, thank you, Martyn. You put a lot of effort into that. Very comprehensive. It was a real insight into something that I certainly didn't have any knowledge about. I knew the sort of basic processes and everything, but it was good to actually see it sort of step by step and what you have to go through. And even as you say, I mean, there's a lot of very experienced scale guys on here, but that's something that they wouldn't even have looked at before. Isn't that right, Mr. Jackson? I don't think you'll have looked at that before, and you've been building scale models for I don't know how many years. So
always managed quite well with a scalpel.
No, all I wanted to just show was really that there was, for those who haven't tried it, there's nothing to be frightened of. The great thing about CAD is that if you make a mess of it, you just undo it. If you're doing it on paper with a pen, the old-fashioned way, using drafting tools, and you make a mess of it, you've got a lot of work to restart, to go back to the start again. And it's to get over that hurdle. That it isn't really difficult. It looks difficult at first glance, but it really isn't that difficult at all. So, if anybody, I said, my email address, I'll read it. It's Martyn with a Y at czd.org.uk. If anybody wants to talk about it or have a chat or got stuck or want advice on the software or want to know where to find a free copy of AutoCAD 2011, I can let you know all that. But I can't help you with DEVFUS. Getting your copy of DEVFUS and so on, but you can download evaluation copies from Stefano. He's a great guy and he's very helpful. If you've got a problem, you can drop him an email and you'll probably get a response back within an hour. It's very good indeed. I've got a lot of time for that guy. He's spent a lot of time and effort on this for what is essentially a hobby market.
Okay, brilliant. Well, thanks very much, Martyn. It's a big thumbs up from me here and from all the comments that are coming in the chat. You can see them as well, so thank you.
Thank you very much.
Your clap from around the world there. In 2 weeks' time, we're hoping that we're going to go to the US, to Ohio, for Mike Barbie to host. So yeah, look out on Facebook, the Facebook group for the details, but all of you guys here will get the invite anyway. So thanks once again for joining, Roger for hosting, and see you in a couple of weeks.